Good morning, guys. Anjani Kumar here, dealing power system 2 for third year electrical students. Right? In the last session, we discussed about how the corona forms. Right? So, how the corona forms means corona will form when a conductor carrying high voltages. Right? So, if it is a greater than 33 kV, the corona will form. That means if these two are conductors, when high voltage transferring means the potential gradient will be increases, right? So there will be a potential gradient. So due to that potential gradient, so the whatever the free electrons, the air is insulator between the two conductors, and some free electrons will be present, right? So when a potential gradient means when the surface of the conductor which is having a more stress, more voltages, so whatever the electrons here, this collide with these electrons, that means the force of the electrons will increases. So due to that force, these electrons collide with the molecules which are in air, then develop another electron and ions, and goes on. These electrons will collide with another molecule and develops an electron. So likewise, as there will be a conducting path between these two conductors, so there will be some arc will be formed, some violet glow will be formed, some sort of hissing noise will be present. So that hissing noise we can call it as a corona. So whatever the gradient that required, how much gradient that we required to whatever the free electrons that will collide with the molecules, right? That means the breakdown of air that happened, right? I hope it's clear. That means whatever the gradient, how much gradient of voltage that required to break down of the air, right? Up to that voltage, it will act as a insulator. If that much gradient present means definitely the electrons force is there. Due to that force, electrons collide with the molecules, then develop the electrons. Likewise, there will be a conducting path between the two conductors. Right? I hope it's clear how the corona forms and all these things. Now we'll discuss about some important terms. Some important terms. Important terms, right? So when you are designing your overhead transmission system, so we should know that this type of corona effect will plays a predominant role while designing your transmission system, right? So we want to make that profitable transmission system. So we need to following terms we need to know. So while designing a transmission system which is having a corona based thing, right? So why the important terms we are considering means whatever the transmission system that you are having, that should be a low cost and low corona effect and more efficient. So how you can make? So you have to follow the things that we are going to discuss here. The first one is critical descriptive voltage. Second one is visual critical voltage. And the third one is power loss. Right? So these are the important terms we should consider while designing your overhead transmission system. We know that the phenomena of corona will plays a efficient role in a transmission system while designing your overhead system. So for the successful design of overhead system, if you need, definitely you should follow these type of terms while designing your transmission system. So what is a critical descriptive voltage, what is a visual critical voltage, and what is a power loss, and all these things, right? So now each and everything we will discuss. The first one is critical descriptive voltage. right? So first I'll write what is a critical descriptive voltage. That means the minimum phase to neutral voltage at which corona forms. That means, so what is a critical descriptive voltage? So the minimum voltage, that means the air breakdown is there, that minimum voltage at which the corona forms. So whatever the gradient, the gradient voltage that required to break down the air, so that voltage we can call it as a critical descriptive voltage. I hope it's clear. Now how it is means, now consider two conductors, the conductors which are displaced by a distance, alright, so where r is the radius, so we have a gradient, formula for gradient, so G is equal to V by R log D by R. Right. So this is the gradient that is developed when high voltage transmitting through a conductor. So what is that gradient? If it is have a two conductors which are spaced by a distance d and which is having a radius r, right? So then whatever the voltage that you applied V, so right, so then the potential gradient, the potential gradient will be developed now. So what is that gradient? At which gradient the breakdown occurs? That is a critical voltage. Right? Here B is nothing but voltage that you applied. R is nothing but radius of conductors. Right? So D is nothing but distance between the conductors. Right? So this is G is nothing but potential gradient, right? So if you want a critical descriptive voltage means at which gradient voltage your breakdown occurs, that voltage we can call it as a critical descriptive voltage. The formula for grading means V by R log D by R, right? At which gradient at which gradient, so how much voltage your air will be breakdown occurs. So this voltage we can call it as a critical descriptive voltage. At which gradient the breakdown occurs, that voltage we can call it as a critical descriptive voltage. See, this is a conductor Now you are applying your voltage, there will be a potential gradient. So you just know at what gradient, how much stress on this voltage, then only the electrons will move fastly to collide with the air molecules. Then only the ionization will take place. But how much gradient, how much voltage, that voltage we can call it as a critical descriptive voltage. So that gradient we can denote it by the G naught. So that voltage we can call it as a critical descriptive voltage or log D by R. So then what BC is nothing but critical descriptive voltage, right? So where BC is equal to Z naught or log D by R. So what is the G naught? G naught is nothing but a gradient at which the dielectric strength of air 30 kV per cmm will crosses, right? So will crosses at some condition, atmospheric condition is there, 76 centimeters pressure undali at 25 degrees centigrade undala. So basically we are considering, so that means the gradient at which the air breakdown occurs. So then only the air ionization will form, the arc will be struck. So that phenomena we can call it as a corona, right? So that voltage we can call it as a critical descriptive voltage, right? That gradient you are getting that voltage. So VC is equal to Z naught R log D by R, where Z naught is nothing but gradient at which the dielectric breakdown. దట్ మీన్స్ 30 kV per cmmని క్రాస్ చేస్తుంది. So basically whatever the atmospheric condition you are taking as 76 centimeters of pressure ఉండాలి, 25 degrees centigrade weight ఉండాలి, centigrade of temperature you are considering, right? So this is the formula for VC, critical descriptive voltage. But basically we are not having this much temperature, so there will be a temperature variations and pressure variation in atmosphere. So for this we need to consider one more term that is called air density factor. So basically VC is equal to Z naught, so G naught or log d pi r. So at 76 centimeters of pressure and 25 degrees centigrade, your air will be breakdown. But so we don't have this much atmospheric condition. So for this, in beyond this one, we need to consider another factor that is called air density factor. So that can be denoted by delta, so which is called 3.92 B by 273 plus T. Right? So basically we are treated as del equal to 1. So in some other cases they will give that the delta value, the air density factor is this much. So then you have to find out the critical descriptive voltage. What is a critical descriptive voltage? You have to consider del or log d by r. This is one more formula, right? And if the conductor is a smoothly conductor or roughly conductor, so for this we require another term that you need to insert it. So that term we can call it as a m naught, irregularity factor. One more term we need to insert it, that is called irregularity factor. So that is called m naught. Some different type of materials, right? Different types of conductors if you used, then you have to insert this one, and total then this is equal to Z naught delta m naught or log d by r. So this is a whole formula for critical descriptive voltage. I'll explain here. So what are the things that you are consider? So what is a Z naught? Z naught means the gradient at which the air breakdown. Okay. So what is a del value? Del value is that air density factor. So if it is 76 centimeters pressure and 25 degrees centigrade, only you are considering G naught. But if it is more than that one, you have to include the air density factor. And after that m naught. So depends on the conductor materials and conductor design also we need to consider. If it is some is a smoothly conductor, some conductors are roughly conductor. So in that you have to introduce irregularity factor. So this is an air density factor. So this is irregularity factor. This is the radius. This is the distance, and this is the radius. And irregularity factor. Irregularity factor, sir, m naught is equal to 1 for polished conductors. Right? So that is equal to 0.98 for dirty conductors, right? Irregularity conductor, dirty conductors. That is equal to 0.87 for ACSR conductors. Right? So in this way you are going to choose your irregularity factor. Right? I hope it's clear. I just want to explain one more time. So visible critical voltage. So what is a visible critical voltage? That means when a high voltage transferring, there will be a potential gradient will be developed, right? At which potential gradient your air will break down and the corona will take place, right? At which voltage your corona will takes place. The minimum phase to neutral voltage at which the corona takes place, we can call it as a visual critical descriptive voltage. Corona takes place. Alright, so what is the formula of this? So G naught. So why we are calculating G naught means at which the potential gradient at which the corona takes place. Right, at which the breakdown occurs. So why you are calling it delta? Delta means air density factor. So why we are taking air density factors? Your G naught you are considering for 76 centimeters of pressure and 25. If it crosses, you need to consider your delta value, air density factor, and one more term which is M naught. So we can call it as an irregularity factor. So why we are taking irregularity factor means it depends on a design of a conductor. If it is a roughly spaced conductor or a dirty conductor, polished conductor, alright, ACSR conductor, so we have to include this irregularity factor. Then what is the radius and log of d by r. So this is the formula for visual critical voltage. This is very important. Critical descriptive voltage. I hope it's clear. So this is the formula for visual descriptive voltage. So we need to by heart this formula, right? Nothing is there. So I hope it's clear, right? No need to by heart this one. So you have to consider the gradient value where the breakdown of air occurs, and you need to consider the air density factor. Definitely they will give the air density factor also. So why we are considering the air density factor means, so there will be a change in temperature and then change in atmospheric condition. So in that situation you have to calculate, you have to insert the air density factor also, and after that irregularity factor. So definitely you need to add the irregularity factor also, because different conductors that you are using. If it is ACSR conductor, you have to take your irregularity factor 0.87. If it is a polished conductor, you have to take your irregularity factor 1. And if it is dirty conductor, it will be 0.9 and around. So we need to take like this. And this is the concept of critical descriptive voltage. Alright, I hope it's clear. Now we move on to the visual critical voltage. We can call it as visual critical voltage. See, right? So what is a visual critical voltage? So the minimum voltage at which the minimum phase to neutral voltage at which corona glow will form. Alright. So what is a critical descriptive voltage? That at which the corona will form, the breakdown of air will form. The minimum voltage phase to neutral voltage at which the corona glow will form. So that voltage we can call it as a visual critical voltage. Right? So if the gradient is increased, the gradient at which the air breakdown occurs, the corona form, it's not the corona glowing. Right, when the electron hits that one, whenever the electron hits, it's some sort of hissing noise will be developed. So that is the concept of corona, right? So when the glow will form, all the electrons, there will be a path between the two conductors. There will be fill up of total electrons. So whatever the air will make as a conducting path between the two electrons. So that voltage we can call it as a visual critical voltage. I hope it's clear. Critical descriptive voltage వచ్చినంత మాత్రాన కరోనా గ్లో రాదు. Just it will makes as a hissing noise and some sort of electrons moving and hits the and collides with the molecules, air molecules. Right? So whenever the two spaces between the two conductors is filled of electrons, it will make a conducting path, then the corona glow will form. Right? So that voltage we can call it as a visual critical voltage. I hope it's clear. Critical descriptive voltage, it's a phenomena for corona formation, right? Not the glow. When the glow form, the two conductors fill with number of electrons, then the glow will form, right? So visual critical voltage, the formula is M naught Z naught C delta R, and we can treat it as 1 plus 0.3 by square delta R. So this is the formula for kV per mm. So this is also voltage kV per mm. So all the right. So this is the formula for visual critical voltage. I'm telling clear. క్రిటికల్ డిస్క్రిప్టివ్ వోల్టేజ్ వచ్చినంత మాత్రాన కరోనా గ్లో రాదు. కరోనా గ్లో ఎప్పుడు వస్తుంది? ఆ టూ కండక్టర్ స్పేసింగ్ ఫిల్ ఆఫ్ ఎలక్ట్రాన్స్తో నిండి ఉండాలి. సో దెన్ ఓన్లీ ద కరోనా గ్లో విల్ ఫార్మ్. సో దట్ వోల్టేజ్ వీ కెన్ కాల్ ఇట్ యాజ్ ఎ visual critical voltage. So for the formula, M naught G naught delta R into 1 plus 0.3 by square delta R. Don't have any derivations with this. So what is M naught? M naught is nothing but irregularity factor. You know different types of conductors you are going to choose. Z naught. What is zeta naught? G naught means potential gradient at which the air breakdown occurs. A delta is nothing but air density factor. Different atmospheric condition. R is nothing but the radius. You know the delta. You know the R. Right? So M naught, different conductors. You have to take M naught value and all these things. I hope it's clear about critical descriptive voltage and critical visual critical voltage. These are two very important. Alright, I'll explain one more time what is a critical descriptive voltage. The minimum voltage at which the corona form. What is a visual critical voltage? You will see that corona glow, you will see the minimum voltage phase to neutral voltage at which the corona glow will form. Alright, so that is called a visual critical voltage. Alright, so corona form, that voltage we can call it as a corona formation. That is called visual descriptive voltage. Corona glow form, that is called visual critical voltage. Hope I think clear about these two things. And definitely another term that we need to know is a power loss. Alright, so when the corona forming means some sort of some sort of energy loss. So between the conductor is in the form of heat, light, some reactions is there. So that loss we can call it as a energy loss, a power loss due to the corona. I hope it's clear, right? So that means when formation of corona, energy loss in the form of heat, right? In the form of heat, light, some chemical reactions, right? So that the energy loss we can call it as a power loss due to corona. So what is the formula for power loss? Is equal to 242.2 F plus 25 by delta square root of R by D B minus BC whole square into 10 power minus 5 kilowatts kilometer per phase. So this is the power loss formula. You just need to by heart this formula. So why the power loss means when forming a corona there will be energy loss. So in the form of heat, light and some chemical reactions, right? So when critical descriptive voltage crosses, definitely the corona will form, then glow will form. Due to that some losses will be developed. Right, so that energy loss we can calculate as 242.2 F plus 25 by delta square root of R by D V minus Vc into 10 power minus 5. You know F is nothing but frequency. So definitely the corona also depends on the frequency. V is nothing but voltage that you apply. Vc is nothing but critical descriptive voltage. Right? So these type of energy laws will make effect on the surrounding communication lines, radio interfere lines. So definitely those lines are going to also affect with the help of this corona. So we need to avoid these type of effects in the transmission system while protecting other communication system around the conductors. I hope it's clear. Right? So this is about the power loss. Right? So what are the terms that we discussed till now? So important terms. So why require important terms means, so corona is a predominant role in a transmission system. So while designing your transmission system, we need to consider the concept of corona. Right? So profitable transmission system, when you are built a profitable transmission system must be depends on the following terms. So we just consider the most efficient power system, efficient transmission system should consider the following terms. The first one is a critical descriptive voltage, that is called VC, and second one is visual critical voltage, that is called VV, and power loss. Right? I don't want to discuss the formulas and all these things. So what is the critical descriptive voltage? That means the minimum voltage at which the corona forms. Right? Minimum voltage at which corona forms. Right? So what is the visual critical voltage? The minimum voltage at which the corona glow will form. Corona glow will form. Right? So what is the power loss? So what is the power loss means? When corona forming, there will be energy loss around the conductor in the form of heat, light, and some chemical reactions. So that loss we can call it as a power loss due to corona. Right? So with the help of these losses, it will affect on a certain communication systems around the conductor. So we need to avoid these type of effects in the transmission system. Right? So what are the formulas? BC, VV, and power loss. So what is BC? You know the formula: Z naught delta M naught or log D by R. Right? So what is the formula for V? Z naught delta M naught or 1 plus 0.3 by square delta or kV for mm. kV for mm. And what is power loss? 242.2 F plus 25 by delta square root of R by D V minus Vc whole square into 10 power minus 5 kilowatt kilometer per phase. So these three are very, very important terms that we need to consider while designing your overhead transmission system while affecting the factor of corona. Right? I hope these terms are clear from my side. So if you have any doubts regarding these terms, make a call and definitely I will clarify your doubts. I hope it's clear. So these are the terms we need to consider. In the next session, this is about this session. In the next session, we'll discuss about what are the factors that are going to be affects the corona, and what are the advantages and what are the disadvantages of corona. And after that, we discussed about how to reduce this corona effect in a transmission system. So those are important theory type of questions that we will expect in our end exams. Right? Till now we discussed about what is a corona, what is the phenomena of corona, how the corona form, and what are the important terms while defining the corona. Alright, thank you for now.